Everybody, welcome back. We're going to be doing some unit testing in Flask today. So this delightful web page that you see in front of you is a Flask application from this guide to Python Flask unit testing, which I will be linking in for you. But basically, this is just a remote API where it's going to render out a web page and you hook up to it with an API key, which is going to be kind of a default, testing API. And honestly, the content is not important. What is important is the ability to, see, search doesn't even work. What is important is the ability to test this. So this could be any Flask application ever. Sorry, coughing like crazy today. Basically, what we want to do is check to make sure that the pages coming in match what we expect. All right, so we want a picture here. We want a particular set of text here, and we're going to write test cases for that. Now, when we're doing a Flask-based server, this means that we're running things in Python. If we were running in Python, we have some options for doing testing. There are numerous modules for basic testing, exploratory testing, all kinds of different things. We're going to be using PyTest in this demo, and that's one of the more common testing libraries I find for Python. There's also Nose, which is another one, but PyTest is pretty straightforward, and we'll kind of see how this works. So this guide has a Git repository that I have pulled down. So we cloned it, and it also uses a virtual environment. Now, don't think I've talked too much about virtual environments in Python, mainly because I tend to not use them, even though I know that's a terrible habit. Basically, what a virtual environment gets you is a nice sandboxed Python folder, effectively. All of the modules that you would download are going to be stored in that folder, and then it doesn't taint the rest of your system. For instance, if you want a particular version of Flask for this particular application, virtual environment, install that version of Flask. That doesn't impact the Flask that you have installed on the rest of your computer or the rest of your Python installation. It's a good habit to get into, honestly, but it's one that I don't tend to do. I'll do it here just to kind of show you what I've got going on. So let me go ahead and reopen, apparently, because I typed exit instead of just intelligently exiting the virtual environment. So you can install virtual environment in multiple ways. I'm obviously using Linux here, Windows subsystem for Linux, so I can just use apt to install it, or you can use Python. It's a pip library to install it, so pip install virtual env. And then we create a virtual environment in here by doing virtual env vnv, and that's what created this folder here. All right, and if we look inside it, we have some folders, bin, libraries, man pages. So again, kind of a Python sandboxed environment. Cat vnv bin activate. Activate is going to be the script that we are going to source to basically load everything in and kind of overwrite our current environment to be using this one. So I want to do source venv bin activate. See this little tag pop up here that says we are in a virtual environment. Now everything Python related will be internal to this folder. Kind of like what we did with Rails, honestly, in the past, where you do bin/Rails and then all your commands. You're referencing the local installation, or the local folder, I suppose. Okay, so back to this. Now we are going to, if we want to run this application, you just make the script executable and run it. So if we do vim run.sh, basically what we see here is a handful of export statements and our Python commands. So these are setting environment variables that our script needs. So that culture mesh site needs an API key. Our WTF library needs a key, and then the culture mesh API base endpoint is basically just the link that we are pulling all of their data from. The Flask server is going to handle rendering all the content, and that's going to be kicked off with run.py. So if we look at run.py, we're going to see a Flask server. We're going to have some SSL information, and our app is going to be in culture mesh. So if we then look at culture mesh, and where's the main page here? client, I guess. New. I just saw it. Where was it? Views? Okay, yeah, views. We have a typical Flask application here. So here's our route. It can be the root or /index, return the index template. We have some headers that we are adding in and some session information in here too. So again, none of this is super important because we are going to be focusing on testing. The application itself isn't really important for us, other than, I guess, making sure that it matches our tests. Just wanted to give you a little bit of background here. So we are going to then have a test file. And I would say if you want to learn a bit about Flask and Python testing, to kind of walk through this guide step by step, if you just check out this tests written branch, then it gives you the tests already filled in, which is what we're going to be using here. But if you want to get a better hands-on approach for writing your own test cases, it's kind of nice to step through. So our tests are going to be in test unit web app. And if we look at tests, just test unit web app, and then we've got test posts, test root, and we're just going to run test root for now. So the way this typically works is that you're going to define a function per test case that you want to run. So this bottom one here, we're going to test the aliases for our home page. So we're going to get the root of our application. So client is basically going to be a mock browser. In a way, we're just getting data, probably just a curl command, honestly. But let's get the landing page. So client.get is going to be that. And then we're going to check to make sure that if we go to /index, instead of just the root of our application, that data matches this data, which should coincide with our routing that you saw a few moments ago in the views page, right? Because we're going to say the slash or /index is the default route. The other one here is let's test the landing page. So let's get the client's data. So same thing as down here, but now we're going to decode it into HTML. This is basically going to decode it from whatever format it was received in. Typically, there's going to be, I don't remember exactly offhand let's look that up. Python decode. Is it? I think it's Unicode. Okay. Sorry, I just wanted to pull this up really quickly. Decode is basically taking whatever formats of data we are getting back and making it string readable. So if it came in as UTF-8 or it came in as Unicode or it came as any other encoding for characters, we're making sure that it's parsable by our program. So that's what we've got going on here. Basically, you're just getting raw HTML code in this variable. And then we have all of these assertions in here for checking, does this code exist? Depending on your perspective, this could be a test suite, and each of these could be unit tests, or this could be test case one. Just kind of depends on how you want to write this. But we are making sure that the appropriate content is in here. So do we have the appropriate links? Do we have text that we are expecting? Did the response code come back as 200? Or if we're navigating to a bad page, did it come back as 404? Now that kind of testing is appropriate here. So let's go ahead and now run this, and they have a script for running it as well. And again, they're going to walk you through creating it, but there is a tiny script that they've written called test.sh, which is actually not that complicated. Really, it's just running PyTest. I mean, that's all it's doing. When you run PyTest to test an application, you have a bunch of test scripts in the appropriate spot, and you just run PyTest, and it will automatically look for all these files, and then it will run the test cases inside of them. The reason this one has a bash script is that it needs these export statements to kick things off again. So it's similar to that run.sh. Now I could just put this right in the terminal and run python-mpytest, and I don't need the script. Same with the run file. But this is kind of a nice way to ensure that everybody has the same installation and the same setup. So let's go ahead and now run test.sh, and we'll get a test report back. And this doesn't usually take all that long to run. Yep, so test session starts. We get some information about what it's doing and should get a few warnings and all tests passed. Yep, 3 passed, 5 warnings. So all these warnings are basically just things being deprecated in the various modules. None of these are game-breaking changes, but be aware that this functionality is going away in the future type of a thing. All right, so everything passed, which means that, no, not test root. All of this stuff passed. All right, so now what we can do is, let's say, assert CIS658 is the best class ever, and I'll fight you in the streets if you disagree. Smiley face. In HTML. This is a very Pythonic thing here too. So is this string in this variable somewhere? Basically, is there a pattern being matched here? Okay, let's run our test again. And we should see a failure because that test doesn't pass. That code doesn't exist anywhere in the returned file. And while that's running, you're seeing it's loading mock, it's loading cov. Basically, we can run code coverage metrics in here to make sure that every single line of code is executed at least once. We could do unit or object mocking if we need to, say, stub out a class or function or something like that. Basically, mock up an entity that we don't want to test that thing. We just want its hooks. But yeah, so here's our failure. We see here this assertion is what failed. Happened on line 18. Assertions, again, if you're not familiar, basically if that test fails, it will break that script. And for PyTest, an assertion is going to act as a failure here. You could do any other thing though, if x doesn't equal y, or if z is in this range, return false or return true or something like that. But we see our test cases fail. And again, this is just some of the most basic unit testing that we could do at all. And just kind of one more thing to show you before we sign off here, because I know this is getting a little bit long. Here's our website, right? So I want to show you that secondary routing test. So if I were to go to /index, I get the exact same homepage. So that's basically what that Flask route was doing there. We'll leave the posts bit alone for now, but yeah, PyTest in Flask, great way to get up and running with unit testing. Okay, I will see you all in the next video. Bye, everybody.